Right, nerves. What I'm going to first show you is a diagram of a general nerve cell, and then we're going to talk about the reflex arc. So nerves look like this in general. This is what I call a generalized diagram. I'm going to start off up here. This is the nucleus. Nerves are cells just like all the others. So my nucleus contains my DNA and acts as the controller of my cell. Now this is my axon. My axon is a long thin projection that comes from the nucleus towards the dendrons, which are these little bits here. And this is the site of my electrical charge. Now an actual electrical charge is generated up here and travels the length of my axon down to my dendrons, each and every one of them. This electricity we call an impulse, an electric impulse. Now an electric impulse is fine, but it's got one or two little problems. I'm just going to say this starts here, kind of in the middle of nowhere, and ends up down there. A few little problems, especially if you've got something as important as your nervous system. So this electrical impulse, while it's useful and everything, isn't useful unless it's fast and well insulated. Now down the length of my axon, I have what are called in A level speak Schwann cells. Right? But we call this my myelin sheath. And the function of my myelin sheath is to, 1, insulate the axon, 2, speed up impulses. Alright? So the function is to insulate my axon, to speed up impulses. Down here in my dendrons, this is where my synapses are. So what I'm just going to do is I'm going to draw in another nerve here, and this is where nerves can connect and communicate. This little gap in between here is a synapse. So if I was to draw a synapse, again very generalized, definitely not how they actually look, I would be able to see a gap in between my nerves. This is my synapse. Now, I've got an electrical charge coming along and finishing at the end of my dendron. Alright? So I've had my electric charge come all the way down the nerve, and it's got to move on to my next nerve. Well, if it finishes at the end of my dendron, that's it. Electricity can't jump through a vacuum, through an empty space. It just can't happen. What it can do, however, is stimulate the release of a whole load of chemicals. Now, if enough of these chemicals land on this side of the nerve, then they will cause another electrical impulse. It's like adding fuel to a fire, and the impulse will carry on down the nerve. So my electrical impulse, because gets carried over the synapse onto the other side. Because of these things, these we call neurotransmitters. Or chemical messengers. So my dendrons are adapted for passing on messages because they release neurotransmitters or chemical messengers from one nerve cell to the other. Now, last but not least, we've got to talk about the dreaded reflex arc. It's actually very, very, very simple. So what I'm going to do is I'm going to draw a couple of very stylized and very poorly drawn, I have to apologize in advance, things. Here is a finger. Yeah, that's a finger. Look, it's even got a nail and little bendy crinkly bits. Now my nail is, oh watch out, gonna touch a very sharp pin. And if that was to happen, we would sense pain. The receptor in this case is my skin. I receive a little warning from my skin that I'm in pain. My receptor is attached to a sensory neuron. Now this could be a pin, or it could be like a spear point or a saber-toothed tiger's claws about to attack you. We don't have the time to think about getting away from this danger. So we bypass the brain altogether and we go straight to our spine. So my sensory neuron will go all the way back up along my finger, all the way through, until it gets to my spine. I'm actually just going to draw that in. When it does get to my spine, it will meet a relay neuron. My relay neuron will take that message and will pass on a translated message to my motor neuron. My motor neuron is the one who is responsible for moving the muscle that is going to move me away from whatever scary stimulus is happening. So I'll just draw in a couple of sheets of muscles there. My motor neuron is the one that's going to cause me to lift my finger. It's the one that's in charge of my muscles. So, getting a pinprick is the stimulus that excites my receptor. My receptor, the stimulus that's happening at my receptor is picked up by my sensory neuron. My sensory neuron then communicates with my relay neuron. My relay neuron is able to translate the message that my sensory neuron has. It's located here in my spine in the CNS, so there's no brain thinking at all. And my motor neuron carries a message to the muscle that's going to cause an effect. The thing that causes the effect is an effector. And the effect of this reflex arc is going to be that my finger moves upwards. Alright, so how do we remember this? Well, you can make up your own mnemonic. Stimulus, receptor, sensory neuron, relay neuron, motor neuron, effector, effect. Or if you're having trouble with that, at least remember receptor, sensory neuron, relay neuron, motor neuron, and effector. My receptor, in this case, was the skin. It picked up the message from the environment, but it could be anything. It could be your eyes, your ears. My sensory neuron brings a message to my relay neuron. My relay neuron, which is in the spine, so that we don't have to think about it too hard, translate this message from my motor neuron. My motor neuron then causes my effector to move, or to be stimulated, which then causes an effect. And remember, a stimulus is something in the environment that causes a reaction, and an effect is the reaction that we have. Okay. Oh, that's not a bad drawing, really.